Hey everyone, it's Mrs. Brimlow, and today I'd like to talk to you about how to find slope for a linear function, whether you're given a set of ordered pairs or a table. So if you have the packet, you can turn to page 25. It looks like this. This is what it says at the top. Or you can get a copy from from Canvas, okay? However, before we dive into this lesson, I actually want to take a minute to go back to our lesson from last Friday on slope and just do a quick review of what slope is. So when we're talking about slope, we're talking about the rate of change or how steep a linear function is. It's how it's increasing, decreasing, or possibly staying the same over time. And in order to move from one point to the next, it has that common rate or constant rate. So when you're finding slope, we say it's the change in y over change in x. So another way they call it is rise over run, which is how I easily remember. And when I'm thinking about this, I think about a set of stairs. And if you think about moving on a set of stairs, if you just go straight into the stair with your foot, you're going to trip and it's not going to feel too good. So before you can move on your stairs, you have to go up or down, depending on which way you're moving on the stairs. So if you're going up a set of stairs, you've got to lift your foot up and then move forward, or you've got to bring your foot down and then move forward. So just think about that when you're thinking rise over run, okay? And so we always go up or down first and then to the right. And the reason we're always moving to the right is because we are reading graphs that way. We read graphs like a book, okay? So we go down and then to the right, down and then to the right if we had to go negative, okay? So this is for positive, this is for negative. And then if it's flat, there's no slope to it, it's zero slope, it's a horizontal line. Undefined isn't even a function, and it would look like this, vertical line up and down, okay? And just like I said, there are several types of slope. We have positive, negative, zero, undefined. So just a few things to think about as we get into today's lesson. So now going back to page 25 in the packet, or if you printed it out. So we use the slope formula to find that change, to find what that rate is from one point to the next over time. So as you can see, I've already started using some highlighters for these notes. I did make a little mistake and I apologize, and I will clarify it in just a second. So we assign one coordinate to be the ones and one coordinate to be the twos. And that's just so you can tell the difference between your coordinates when you substitute it into the formula, finding your change. Your y's should always be at the top, x's should always be at the bottom, and whatever y you put first, its corresponding x should be first, okay? So in this case, they've said y2 is going to be 1. So we're going to do 1 minus, okay? And then whatever y1 is, which is 5. And then we have to go back to this ordered pair and start with 8 and then minus 2. Okay, so once again, y minus y over x minus x. And you're going to notice that vertically they form an ordered pair together. So 8, 1 was this ordered pair, 2, 5 was this ordered pair. 1 is my y2, 5 is my y1. So 1 minus 5 over 8 minus 2, x2 minus x1. When I simplify that, I get negative 4 over 6, which would be negative 2/3. So this tells me that this, if I don't have a graph, I know already that it's decreasing, it's going down. I'm not sure how you see it for me, but whatever way is showing that you're moving down as a negative slope at a rate of 2/3. Okay, so it's a little bit of steepness to it, but not super steep compared to something like 3 or 4. Okay, so given a pair of ordered pairs, this is how you could find the slope. And if you have multiple ordered pairs for a function, you can pick any two. When you simplify that rate, it's going to be the same. It's going to have the same slope because they're all on the same line. So any two ordered pairs for a function you can use to figure out the slope. Okay. So same exact way you can find it for a table. So you pick out your coordinates. And once again, there are multiple coordinates in this table. So they picked out 0, 1, negative 2, 5. Okay. So I'm going to just do a little bit of highlighting. This just helps me. So y2, what I'm going to start with is 5. And then I'm going to subtract y1, which is 1. So I'm going to go ahead and write that. So 5 minus 1. So, okay. All right. Then next I've got -2, which is x2, minus 0, which is my x1. Okay. So -2 minus 0. So when I simplify that, I get 4 over -2, which is -2. So this also has a negative slope to it, which means the graph would be decreasing or going down over time when you look at it from left to right on a graph. And it would be a little bit steeper compared to the last one because 2 is bigger than 2/3. Okay? When you're working with a table, there's another way to find slope, which I'm going to show you right now. And once again, my job is to give you all the tools, all the strategies I have, and then you figure out what works best for you. When you have ordered pairs, you have to use the slope formula. That you don't have another option. When you're given a table, you can use the slope formula. The slope formula works every time as long as you use it correctly. The other thing you can do with a table, which is what I like to do, is you can see how it's changing over time. So the change in y is -2, they're subtracting 2. Change in x is adding 1 because you're going from -2 to -1, which is technically an increase because we're getting closer to 0. From 3 to 1 is -2, and this is also still +1. Here is -2, and here is +1. So we can see this is the change in y over change in x, and that's exactly what we had using the slope formula. Okay. So today you're going to practice finding the slope, what the value is or rate of change for linear functions given ordered pairs or a table. So you can either do whatever work is an option in the packet or whatever is offered online. If you have any questions, let me know, and I will be chatting with you guys soon.